Good day, guys, and welcome back to my channel. So today we'll be solving questions on the Picard method of approximation. Actually, this method is just like, okay, you having Euler's method, Taylor's method of solving normal ordinary differential equations. So we'll be solving few questions. I might solve one now, and then the next video I'll solve another one. So you can do well to subscribe to get notified, and then turn on your notification bell so that you get notified when we post the next video. So the first question goes thus: using the Picard method of successive approximation, find the third approximation of the solution of the equation dy over dx equals x plus y squared, where your y equals 0 and x equals 0. So I'll be giving you tips. This is it. You're going to understand, and also I'll be giving you tips that you're going to use to understand, so you don't just cram and forget it. So the first thing is, when you have y equals y naught and x equals x naught, it implies your y equals 0 and x equals 0. It implies your y naught equals 0 and x naught equals 0. You should have that in mind for now, that when you have this, it implies that your y equals 0 and y naught equals 0 and x naught equals 0. So going to the solution, you recall that under Picard method of approximation, we have an initial value problem. We call it IVP, such that you have your dy over dx equals f of x comma y. So it means that in my question, I have dy over dx equals x plus y squared. Similarly, it implies that my f of x comma y, since this is equal to this, therefore, okay, this is equal to dy over dx equals to dy over dx. Therefore, f of x comma y is equal to x plus y squared. I think that's more better. That's more nice to explain in that manner. So now, I said you should always take note that when you have this y equals 0, x equals 0, it just implies that your y not equals 0 and x not equals 0. So another thing you should take note under Picard method of approximation is the nth approximation formula, which is given as this. It's very important. So you have y n of x equals y naught plus x naught plus integral from x naught to x f of x comma y n minus 1 dx. What this formula is saying is so straightforward and simple, you don't have to cram it. It implies that when you are given you are looking for, you can under Picard you can be asked to look for different number of approximation of the solution. So this n varies from 1, 2, 3, 4, 5 up to any number that you have been asked to look for the solution. So your y naught is standard, is always y naught here. Then f integral from x naught to x. Now you already know that in your question, definitely they will always give you your x naught. Your x naught can change, they will give you, but your x will stay. You don't know the value of x yet. Then f of x comma y n minus 1. This y n minus 1 implies that, let's say for example I have y2 here. It implies that here I will have not some 1 minus, like 2 minus 1. That means if I have 2 here will just be 2 minus 1. That means I have y1. So if I have y3 here, I will have y2 here. If I have y4 here, I have y3 here. If I have y10 here, I have y9 here. If I have y100, I have y99 here. So it's just straightforward that way. So since you know this, we're looking for the first approximation. It implies that my n equals 1, x equals 0 from the question, and y not equals 0 so from the question. X not equals 0, excuse me, and y not equals 0 from the question. So therefore, anywhere I see n here, I put 1. So that means I have y1 of x, same thing as y1, equals y naught plus integral from, what's your x naught from the question? 0. So 0 to x, f of x comma, now this is going to be y naught because I have 1 here, right? So 1 minus 1 will give me 0 dx. Now recall that our f of x comma y is equal to x plus y squared. So therefore f of x comma y naught, this should be naught, the naught should be done. So f of x comma y naught should be equal to x plus, no more ordinary y again, but y naught squared. You just have to change the y to be y naught. If you have y1 here, it should be y1. If you have y2 here, it should be y2. So automatically I have my y1 equals, what's my y0 from the question? We said y0 is automatically 0, then plus 0 integral from 0 to x plus, I told you what our f of x from our y0 is already, so x plus y0 squared dx. So same thing, so I have y1 equals 0 plus integral from 0 to x plus y0 squared dx. So I already know that my y0 equals 0 from the question, so therefore I have it to be y1 plus 0 plus integral from 0 to x plus 0, and x plus 0 is still what? X. So I have to integrate this x here, so therefore my y1 will be equal to integral. When you're integrating, you will increase the power of your x by 1 and divide it by the total number of your power. So here my power is 1, so 1 plus 1 is 2 over 2. Now taking it from 0 to x, so therefore I have my y1 to be equal to, anywhere I see x, I put x there. So let's say I have 2 here. Let's say I have 2 here. So it implies that anywhere I see x, I put 2. But here I'm having x, so that means anywhere I see x, I put x. That's why I have it to be x squared over 2 minus, this is going to be y1 equals x squared over 2 minus 0 over 2. And 0 over 2 is 0. So that's why I have it to be x squared over 2 as my first approximation. Similarly, going to the second approximation, we have n. Second means your n is equal to 2. Your y not is still 0 from the question, x not is still 0 from the question. So now I'll recall that my nth approximation is given as yn equals y0 plus integral from x0 to x f of x comma y n minus 1 dx. I told you that you need to know this, it is very important. So next I said n equals 2, so therefore I have to put 2 anywhere I see n. So I have y2 equals y0 plus integral from, what's my x0? 0 to x f of x comma, I told you if you have 2 here, you have 1 here. That's 1 minus 2 minus 1, that's 1. So dx. So automatically you have y2 equals, what's your y0? 0. So the main thing is you know this formula. Trust me, when you know this formula, everything is solved already. Just have to start to impute what you have in it, and then in the next question I'll be explaining, giving you a few tips on integration. But for now, you don't really have much integration in this question, so you need to have basic understanding under integration too, for you to be able to work well with Picard method of approximation. So as I was saying, you have y2 equals 0 plus integral from 0 to x plus, we said f of x comma y, and initially your f of x comma y equals x plus y squared. So if I'm having f of x comma y1, it implies that instead of me just having ordinary y, I just have to have 1 beside it. So I have f of x comma y1 equals x plus y1 squared. So I come to the next line, I have y2 equals y0 from 0 to x. Y2 equals y0 is what? 0. So I just have 0 here. Then from 0 to x, integral from 0 to x plus, what is our y1? Our y1 from the first approximation is 1 over 2 x squared. So I just insert 1 over 2 x squared here. But don't forget, it states y1 squared. So after inserting my y1, which is 1 over 2 x squared, I still have to square it. So after squaring, I put my dx. So here I have integral from 0 to x. This x is still here. So after squaring the whole bracket here, I have 1 over 2, or same as 1 over 4, or same as x raised to the power 4. That's 2h times 2. That's x raised to the power 4. Then if you square this 2 here, you have 4 dx. Then you take your integral. So I told you add 1 to the power divided by total power. So I have y2 equals x squared over 2, because the power here is 1. 1 plus 1, 2 over 2. Plus here is 4. So 4 plus 1, 5 over 5 times the 4 here. That is why I have x raised to the power 5 over 20. Then I take my limit from integral from 0 to x. So therefore, the boundary. So you start from the upper minus lower. So therefore, here I'll have x squared over 2 plus x raised to the power 5 over 20 minus, I didn't just write it here, so if I put 0 here, what will happen? All this thing will turn to 0, so that's why I didn't have it here. So going to the third approximation, we have third means n equals 3. Then you always need your y2, because when you're coming to this nth approximation, if you have 3 here, that means you need 2. So therefore your y2 equals to this second approximation. It is y2 equals x squared over 2 plus x raised to the power 5 over 20. And from your question, it is constant that y naught equals 0 and x naught equals 0. So therefore I have y3 equals y naught plus integral from x naught to x f of x comma, what will I have here? Y2 squared. And don't forget that your y2 is this, so that means I have to square this. So to continue, I have y3 equals 0, so plus integral from 0 to x plus y2, so the same thing. Then you recall that your y2 is x squared over 2 plus x raised to the power 5 over 20. Then after writing this, you still have to square it, then your dx, since you are integrating in respect to x. So I have my y3 equals integral from 0 to x. So I'm trying to do this explanation here just for people that have little issues with expansion. So this is what you're going to do. When you say square of this, it means you are multiplying this twice. So I take the whole of this, multiply by the whole of this. So therefore, then you take this first man, multiply by this man, take this first man again, multiply by this man. Then I go to the second man here and multiply by this lady here. Take this man here again, multiply by this lady here. So therefore, I now say x, normally I have this x here, then plus x plus x raised to the power 4, because it's x squared times x squared, that's x raised to the power 4 over 4, x squared times x raised to the power 5. Indices, you add both, add the power together, that's 5 plus 2, x raised to the power 7 over 40, because this 20 times 2. Then going to the second man here, x raised to the power 5 times this, x raised to the power 7 over 40, x raised to the power 5 times this, 5 plus 5 is 10, 20 times 20 is 400. So that's why we have this dx. So you integrate this everything with respect to x. So if I integrate x, I have x squared over 2. Integrate this, don't forget you add 1 to the power divided by theta power. So this x raised to the power 5 times over 5 times 4, then plus 2 x raised to the power, no, this is 2 here 1, 2 here 20. So this is the same thing as x raised to the power 7 over 20. So I can just say x raised to the power 8 over 8 times 20. So then plus x raised to the power 11 over 400 times 11. So to just simplify it, I'll say this is x squared over 2 plus x raised to the power 5 over 20 plus x raised to the power 8 over 8 times 20, 8 times 2, 16, that's 160. So plus x raised to the power 11 over 400 times 11, that's 4,400, 44400. So, and that's the solution. That's the third approximation. If you can recall, the question states that you should find using the Picard method of approximation, find the third approximation. So this is the third approximation and this is the final answer. So don't forget, the step is just for you to know that when you have the question, your y naught is what you are given as y, and then your x naught is what you are given as your x. Don't forget that your x is not standard, so it's your x naught that will be given to you. What else? You should also know that you should also know the nth approximation formula, which is given as this. Then you should also have sound background under integration. So you can subscribe and turn on your notification bell for us to for you to get notified when we send the next question. All right, have a nice time.